Welcome to Terrible Lizards, a podcast about dinosaurs with Dr. David Hone and Iszi Lawrence. Hello everybody, and we've got a very special Terrible Lizards because we've got a world exclusive interview with the author of a brand new dinosaur book about dinosaurs, and that author is Dr. Dave Hone. His book is out tomorrow, which is what, Dave? The
24th of March.
So, which is tomorrow? Oh my goodness, or today? I can't remember when we're dropping this. I think we're dropping it's out on Thursday and today's Wednesday.
That's the date I've been given, though I think pre-print copies have gone out to some people already and there are reviews floating around.
Of course they have. Only to exclusive people so they can leave amazing reviews about how amazing the book is. So why don't we let you introduce the book? What is the book called and why did you write it, please? Thank you.
It's called The Future of Dinosaurs, which hopefully my publishers aren't listening because I still don't like that title. I had a massive row with them over this.
Oh, it's clever. It's a clever title because dinosaurs are in the past, Dave.
Yeah, I know.
They're in the past.
I know. So I wanted to call it What We Don't Know About Dinosaurs, which is really what the book is about. Though we've got a subheading which sort of says that. But they said that was too negative.
It's a bit negative because who wants to know what we don't know?
Well, yeah.
That's a bit weird. Like, all right, we don't know that. So that's like having a words that don't exist dictionary.
Well, which of course there's been two of them by Douglas Adams. So it's not like these things.
The meaning of lift.
Yeah, and there was a follow-up which I can't remember. But anyway,
there must be a dictionary of words which are in other languages that don't exist in English.
I don't know if there's a dictionary. There's certainly been various lists of them online. But we're kind of getting off topic very early on, even by our standards.
Yes, this is about promoting a wonderful book which people can pre-order right now. Thank you.
So yeah, you're right on the face of it. It sounds like there's obviously lots of things we don't know, and indeed there's lots of things that almost like we don't know that we don't know. You know, what new species are going to be discovered? Well, we're probably going to find some tyrannosaurs, we're probably going to find some diplodocids, but we don't actually know what we're going to find a lot of the time. But what the book is really getting to is obviously it starts each chapter by having a bit of a state of the art and recent discoveries and the state of knowledge of a given subject. So I've got things on anatomy and colour and behaviour and the extinction and all these different areas of dinosaur research. And so, you know, obviously start each chapter kind of go, this is what we do know, this is what we discovered recently, this is the state of the art. And then the two areas that I'm really talking about in every section are things we don't know yet that we're probably actually able to work out, give us enough time, or if we find the right fossil or stuff that we're starting to do, and things that actually we know we would like to find out, but actually are probably impossible. And these are near enough permanent gaps in our knowledge and understanding that we'll never really be able to solve. And don't think anyone's ever really tackled either of those, let alone both together in a single effort. So here's my effort.
You're basically trying to predict the future, going how we will know what we will know, and why we won't know what we will never know.
So a really good example, I think, is colour. You know, we've talked about this extensively, and I and other people, you know, even 10 years ago would say, not only is colour something we don't know, it's something that seems almost impossible to work out. And then we discovered that you can, you know, fossil melanosomes can preserve, and that we can work out roughly-ish what colour those melanosomes are, and we're now starting to piece together dinosaur colour. But we're at the absolute start of that. You know, it's been done for a dozen dinosaur species. In every case, it's only been done for one individual. So and as we've talked about, you know, there are various gaps in that understanding. You know, there's colours that we can't detect very easily. There's structural colour, and the organisation and orientation of those melanosomes can change the colour, potentially quite dramatically. We haven't solved that yet. And so when you look at something like Anchiornis, this little feathered thing from China, which is famously, you know, it's black with some white dots and then some, you know, red plume on its head. That's been done for a specimen. Is that a male or a female? Is that an adult or a juvenile? Did they seasonally change their colour when it got cold? We know it's cold and snowy in winter. Did they go white?
I mean, it sounds like it could blend into nighttime snow. Really well, black with white spots.
You know, but, you know, was it melanistic? Was it, you know, effectively a black vert? That would be extremely unlikely, but it's possible that individual had far more black pigment than the typical one. It probably changed over time, as in over hundreds of thousands, millions of years. Anchiornis probably had a pretty widespread geographical distribution? Was it different in different areas? None of this work has been done. So the idea that we understand colour even for just Anchiornis because there's one which we've sort of worked out the colour for really doesn't tell us very much. And all that other stuff is extremely interesting because that's when we'll start learning about things like sexual dimorphism, adaptation to local environments, and shedding and plumage change and camouflage and sexual selection and signalling and all of that stuff. That's all things that we probably can do given the right discoveries, or in the case of Anchiornis, actually, we've got something like 1,000 specimens of Anchiornis sitting in various museums. If we go through and analyse all of them...
We get enough PhDs with enough motivation to go through enough museum shelving.
Well, yes, and we'd have to develop our method because until recently, or I think even now, it's basically destructive, so you have to actually damage the fossil to get those little points out to put them under a scanning electron microscope to look at the melanosome.
A big scanning electron microscope would be amazing.
That you could put a whole one in. But that, I think, is a really good example of the kind of stuff that's in there. Colour is by no means resolved. We're just starting, and actually the possibilities of what that could tell us, even just for that one species, let alone loads of them, is infinitely more interesting than this one was probably black with a bit of red and white on it. And so that's absolutely an area. I think it's a fairly safe prediction on my part. We're absolutely going to get better at that. We've got the fossils. There are more fossils still coming. Our techniques are still improving and refining. More and more people are looking at this. It's absolutely going to take off sooner or later. And that will massively inform our understanding of their biology. We just haven't really done it yet.
Why not, though? Why not now? Why don't you do it now? Why didn't you do that instead of writing the book? Why?
Why didn't I do it? Well, drop me a couple of million in research funding and we'll try and get round to it. I don't go into this, but, Anchiornis is quite a good example in that regard, because a whole bunch of specimens have been dug up by random people, basically farmers and fossil dealers and people like this. They have not been systematically catalogued in when and where they were found, and particularly the exact fossil layers. And as you may remember, we've definitely talked about this in the past at some point, that bit of northeastern China, so the Liaoning region of these famous feathered fossils.
Feathered fossils, it's a tongue twister.
Yes, it took quite a long time for us to realise that actually there were two distinct separate formations here, one of which is early Cretaceous and one of which is around the end of the Middle Jurassic / start of the Late Jurassic. In other words, they're 20-30 million years apart from each other. But we didn't know this, so there was this classic inverted commas J-hole biota, because it was a J-hole formation, and it rapidly became clear that a bunch of things from the inverted commas J-hole are not in the J-hole at all. They're from this lower level, including Anchiornis.
So is that because there were two volcanic explosions several million years apart?
Basically, yeah. And of course, people, when a lot of these early fossils were being dug up by farmers or prospectors or people who just wanted the fossils to sell them, even if they were selling them to museums, the detailed geology wasn't being looked at. And, this guy would say, I got it from this hillside, and he couldn't tell you exactly where he got it from. Even he might even have got the wrong hillside. No one knew exactly where loads of this stuff had come from, and it was understandably a reasonable assumption that all of this stuff was basically one thing. And so it took quite a long time to work out that it wasn't, and then to try and work out, all this stuff we've been looking at for 10 years, which one comes from which bits?
Eesh.
And that's still going on. And so, yeah, I've been to a museum out in eastern China that was a quasi-private, quasi-public entity. I don't know what its current status is now, but it doesn't really matter. But yeah, they claimed to have 1,000 specimens of Anchiornis, and certainly I saw a couple of hundred while I was there, so they definitely had loads. But when you asked, where did you get these? They were all bought from fossil dealers. So not a single one could they tell you roughly where it came from or exactly what fossil bed it came in. So as I said, that kind of lovely question of, did it evolve over time? Like, do they start without a red head and then they evolve it? You can't tell from this data set. Some some of them might have red heads and some of them might not. But that might be, going back to that classic hadrosaur idea. There was the idea that the crested hadrosaurs were males and the crestless ones were females, until it turned out that they don't appear in the same strata, which is probably an indication that they're not. But we're in that exact same problem here. We could find that half of them are red and half of them are not and go, ooh, male and female. But it's like, well, maybe all the red ones are later and all the black ones are earlier.
And there's no way that you can just get an atom and they've got each little atom's got its geolocation and position scribbled on it somewhere.
Yeah, in theory,
timestamp.
In theory, you could start looking at the really detailed geochemistry, but you'd need to sample thousands of locations for everywhere that everyone's digging fossils up, and sample all the fossils and make sure that they line up properly, because there's probably quite a bit of variation there.
I mean, humans were breeding at a huge rate, so maybe there'll be the funding for this. I think, there's got to be jobs out there for... No, it does seem like an impossible.
It's not going to be easy to fix that. Given how much feathered stuff is coming out of these places, you're probably better off ignoring the stuff that we've already got and just start with the stuff that has been catalogued and catalogue more as it comes out and work from there. But irrespective of that, my general point still stands, which is we have got those fossils, they're coming out in sufficient numbers, we know we can pull colours out of them, that, all these ideas, particularly my own work, but lots of other people as well, talking about sexual selection and talk about crypsis and colour patterns that might allow you to hide, and how that matches up with different degrees of eyesight of these different animals, suggest that some are nocturnal, all these things. We can piece that together. We just haven't done it yet, and it might take decades. But the core of that concept scientifically and the core of the data we would need to do that is available, or at least can be dug up.
So that's one example, I think, probably of many, where we've got the data, we just haven't got the minds and the numbers to crunch.
just the body. It takes time. This is a common problem in paleontology. I see this all the time with, comments that you get online and Twitter and Reddit and places. They say, well, why haven't they dug more of this up yet? And it's like, because it's incredibly expensive to go prospecting and digging for fossils. And there's no guarantee you'll ever find that one thing that you're looking for. Cryodracon, the big Ashdarkid pterosaur I named a couple of years ago.
Hey, is that the one that you went on TV and they asked you if it was a dragon?
No, that was someone else's. No, that was...
that was someone else's, sorry.
Yeah, sorry, it was one of the Australian ones. So there's a whole bunch of bits in the Royal Tyrrell Museum that are all collected from Dinosaur Park. Don Henderson, one of the curators there, told me that they went out one year and he and Mark Mitchell, the guy who Borreo Pelter, Mark Mitchell is named after, Don and Mark went out prospecting, and they basically spent a summer where their whole digging plan was to find pterosaur material. They knew there were these bits, they wanted to find more, they knew it's very rare and hard to find. We're going to go and find some. And they found none in an entire field season.
Whoa.
And this is entire...
Are they rubbish though, Dave?
No.
Are they actually rubbish?
No, the pterosaurs are just very few and far between. And so even, and of course it's very easy to be distracted, but even if you're trying to, not look for anything else and go, oh, well, that's interesting, we'll just mark it for someone else and we're not going to spend more than 10 minutes looking at this, we're going to keep looking for pterosaurs. And they just can't find any. So they just, oh, well, why have you dug more up yet? Well, because it's really not that simple. The Antarctic is the classic one for that. People are like, we found Cryolophosaurus, we found stuff on Antarctica. Why haven't we gone back? It's like, because the average dig in Antarctica costs a couple of $1 million and you might come back with a handful of fragments. Not worth it, or at least it's very hard to justify a lot of the time.
I mean, are we wanting, therefore, what would be best? To have a really sort of megalomaniac capitalist like Musk come along and just throw all his money at dinosaurs? Is that what we want? Or is it better that we slowly realise that the general knowledge and we ask for government funding, which is the best?
Well, years ago, I made the slightly tongue-in-cheek suggestion that all the word science funding should be directed into paleontology.
Well, I mean, curing cancer is just not sexy compared to digging up.
Okay, but the idea behind it is that, if you compare that to most other sciences, the answers that you're looking for can come at any point. You look at something like the James Webb Space Telescope, as we record, just finally unfurled, cost like 10 billion or whatever it was. And that's going to see distant galaxies and planets and star chemistry and all kinds of fascinating things. But it could do that today, or it could do it 200 years from now, and it would make absolutely no difference pretty much to what it did and how it did it.
technically, deep space is moving away from us all the time.
Well, okay, right, but it's probably going to be able to find the same things. And
the universe is expanding. We're losing information.
Okay, but
not as fast as eroding dinosaur fossils.
But yeah, that is obviously where I'm going. Whereas every single dinosaur, there is a finite number of dinosaur fossils. The Mesozoic is long gone. The Earth is subducting. Things are eroding. If you don't dig it up, it's gone forever, and you're never going to get another one. Like that. That's it. It's gone. And so, actually, if you ever want to get that stuff, literally now or never, for everything that's available. Again, tongue in cheek, but yeah, we should stop describing it. We should just dig them all up. Just dig up every single one we possibly can, stick them all in a warehouse. We've got them. Then we'll start working on them.
And the thing is, nothing bad can happen to warehouses.
Yes, well,
we know this.
Yeah, yes, or museums, which definitely don't get burned down or collapse during earthquakes.
And there aren't new creatures that could evolve to eat plastics and nylon and things, so there's no way that our records will be damaged.
Yes, of course. As I said, I wasn't being entirely serious, but these are absolutely real issues. I should say at this point we're drifting off from the book, which I think is no bad thing.
Sorry.
Well, it stops this being a Just Dave's Book episode.
But people want to know about your book, Dave. That's the whole point of this episode. It's the want to know, should I get it? Yes. Should I buy this book? And the answer is yes. Yes, you should.
So we've talked about, things we definitely, or things we probably can know, or that we're on the cusp of knowing.
Well, we talked about colour as one of those things. We haven't talked about all of them.
No, but just to give an example of the other side of stuff we pretty much can't know.
What they called each other.
Yeah.
Names.
Things like island faunas. So islands are famous, notorious for producing
weird stuff.
Really interesting and unusual stuff. If you're isolated on an island, you're free often from a lot of the usual competition, a lot of the usual predators, maybe parasites and diseases and all kinds of other things. And that means either lineages which have died out elsewhere can persist, those things like lemurs in Madagascar, or things can radiate and produce all kinds of weird things like marine iguanas, flightless cormorants, all the finches in just in the Galapagos. And then you've got, kiwis and kakapo in New Zealand, and the flightless rails in all kinds of different places, and clubbed-winged geese, and massive bird diversity you get in places like Hawaii.
I hate to get you off topic very quickly, but it is a dinosaur. A clubbed-winged goose. What is that? Is it a goose that holds clubs?
No, there are a whole bunch of waterfowl in general, and geese and ducks in particular, which have either ball-like lumps or even spikes in their wings and beat the hell out of each other with them.
Cool.
Yeah. Yeah.
Is there a massive battle up in Canada with the seals? I'm just sorry. Anyway.
Yeah. And then even stuff which is extinct but relatively recent, so stuff like the dodo, elephant bird, moa, all of these kinds of things are on islands. And not just islands, they tend to be volcanic islands. And if you
lava destroys stuff.
Yeah, if you think about, volcanic islands, they're very, very steep and pointy, which means they don't have lots of nice, calm rivers and floodplains and lakes and the kind of things that are very good for burying stuff, which is kind of what you want for fossils. They also have a tendency to kind of explode or sink into the sea, and or explode and sink into the sea and then be subducted, because by definition they're often where two plates meet and everything is very, very active.
Can I tell people what subduction is? Because it is a thing that I learnt about when I did geography.
Yes.
Subduction, for example, when you have a tectonic plate like the Juan de Fuca plate, which is a real plate.
I wonder why you remember that one.
Because it's a subduction zone.
Right.
That's why I remember it, Dave. Anyway, so the plates can either meet and they crush together and they go up, or one can go under the other, or they can move apart, and that's the middle Atlantic. That's where you get Iceland and islands, because the plates are moving apart and the lava comes up and you get islands appearing overnight. But some of them, they travel underneath the other plate. So they basically, everything that's on that landmass will, when it enters the sea usually, but it will just turn to lava and be recycled in the beauty that is us having. Apparently, did I read it or did I hear it? But Venus doesn't have tectonic plates.
No, it sounds familiar.
And because it doesn't have tectonic plates, once in a while, because it still builds up all that pressure, the whole planet's surface just becomes liquid rock for a bit and then solidifies again.
Yeah, that sounds like a good place to live, yeah.
It's just terrifying. It's just like...
In addition to the, like, sulfuric acid rain.
But there's no volcano, so it's fine. It's just once every several million years, everything dies. Amazing.
Lovely.
But hang on, I know when people are listening to you talk about volcanoes, they're like, but hang on, you've just been talking about those places in China, those wonderful, like, fields where it was volcanic ash that caused all of these wonderful things. So how come volcanoes are bad for fossils?
There are lots of different plates that do lots of different things. You know, there are places like Italy with Vesuvius where there is a big volcano which can stick ash out, but it's not like Italy is about to fold under Africa. And that's effectively the condition we have in Liaoning, so great for producing ash for burying fossils, whereas something like Hawaii is, you know, sooner or later in the scheme of tens of millions of years, either going to explode or be underwater. And that's pretty terrible for making fossils.
I think you're just anti-Hawaii. That's all you're
Not
doing.
really. But it therefore leaves us in this extraordinary position whereby we would predict from what we understand of, you know, island evolution, island dwarfism, island giantism. We know these are absolute phenomena. You get giant tortoises on loads of different islands for this exact reason. Evolution of flightlessness in lineage in birds, that's really, really common. All kinds of weird, either late survivors or very unusual radiations of things we're going to get on islands, particularly volcanic islands. We also know they're absolutely appalling for making fossils in the first place. Even if they somehow did, they're probably going to be destroyed sooner or later. So in terms of, if you think dinosaurs are weird now, wait until you see what evolved on the islands, but we'll never know.
Unless time machines.
Well,
Still got my hope up.
There's one slight exception to this, because there is one bit that we do have a good record of, if you can remember.
It's not... Well, I'm thinking of Europasaurus, so I'm thinking
Yes.
there must be somewhere in Europe.
Yeah, it's modern Transylvania.
Cool.
And yeah, we have these chain of what was a series of small islands, as a bit of an archipelago, not volcanic, to my knowledge, and relatively close to the mainland, so not as extreme as you might expect for Hawaii, the Comoros, New Zealand, places like this. But yeah, what do we get? Dwarf sauropods, weird short-necked giant ashdarchids, okay, that's a pterosaur, and Bulur bondok, which we talked about before, this weird...
Oh yeah, we did talk about Bulur.
double-clawed thing, which was supposed to be a dromaeosaur and now probably is a giant early flightless bird. So actually, yes, there is a dinosaurian example where we have a bunch of islands and, yeah, all the dinosaurs are really weird down there. So that is exactly what we predict. And again, that's not a particularly weird set of islands compared to, again, things that we know that are comparable. And so again, yeah, I'd expect the volcanic equivalents of Hawaii and the Galapagos to be way weirder. And turning into pterosaurs, which of course I don't mention in the book at all, but this is the perfect point to bring this up, because it comes up semi-regularly, is people go, why haven't we found flightless pterosaurs yet? Loads and loads and loads of birds have evolved to be flightless. Why didn't pterosaurs do it? And I think one of the big answers for this is, if you look at where you get flightless birds, there's two big categories. One are water birds. So there's a whole bunch of flightless grebes and things like that live on really big lakes, and they've basically become more aquatic and less capable of flight. And none of the pterosaurs ever really went down that route. That none of them were great swimmers that we know of.
Too many Spinosaurs.
Swimming adaptations. And the other thing is things that live on islands where there aren't any predators around. Well, we don't have those islands, so why would I'm sure the pterosaurs got there. They probably evolved to be flightless, but we're not going to find them.
I mean, Quetzalcoatl probably was pretty much... I mean, it flew, but not for very long, surely. It was more of a walker thing.
No, that's something that flew perfectly well.
Quite a lot. Okay.
So Quetzalcoatlus and these really giant ashdarchids, it's multiple been times suggested that they're either flightless or that they became, as they got bigger, they became flightless. And there's no evidence for that whatsoever. They all appear to be perfectly
It's just freaky to think something the size of a giraffe just flapping around. That's just...
Oh, yeah. But as we talked about it, they have some adaptations to this that a lot of other things don't.
It's still weird.
Birds don't. And so they're probably rather better flyers than birds were, pound for pound, kilo for kilo. But yeah, so there's my other big...
answer to that.
Or good example of that kind of thing. Like things we pretty much can't know. Yes, we do have Hatzeg and these Transylvanian islands. Great, but that's one set that's not that well known, and it's certainly not as extreme as we would expect from, truly isolated oceanic islands. skeletons and the capacities of these animals to get there and then evolve is exactly what we predict. And yeah, we're just not going to see it.
So are there other things that you think will definitely come to light, or things that you think are likely? I mean, what way is the research going?
So there's some things which are just kind of inept. So like sauropod skulls, I think we've talked about this before, but we've
talked about the hilarious idea that as they die, their neck, they flop to the ground,
flop and
their
explode.
neck flops and they hit their head on the ground and it explodes.
Their heads just explode. But yeah, we've got, I'm trying to do a rough calculation, like 300, 400 sauropod species, something like that named now. There's something like 15 or 20 good skulls between them, and things like Camarasaurus has got 3 or 4. So it's not like it's nicely evenly distributed among them. Several species got a load of good skulls and most of the others got absolutely nothing. That's pretty much only a matter of time. We're going to keep digging sauropods up. We're going to keep finding more sauropods. We're going to start finding more skulls sooner or later. We're never going to make that gap up. But
unless they all really did fall to the ground, and as they flop, smash their heads, and that's actually how they die.
Well, sooner or later...
They don't die of anything else, they just trip.
I mean, sooner or later you're going to get lucky and find one, that fell over in the water or in the mud or something. But yeah, there's an example of something which is a frustrating gap. And yeah, I think it's impossible to predict if we're going to fix that problem in 20 years or 50 years or 500 years. But we're going to find a bunch of more sauropod skulls if we keep digging. We just are. And that will start answering some big questions about, that tells you what their brain is like, that tells you what their eyes and ears are like, that tells you what their teeth are like, it tells you like their jaw function and how their muscles operate and
their nose.
Everything. It's a massive, massive gap in our knowledge. So that's one. Another similar one is, just stuff where we've done really detailed studies. So like, if you look at T-Rex, we talked about this before, T-Rex has become something of what we call a model organism in biology. So much research has been done on it that when you want to do your next little study, you pick the thing that we already know most about because it's easiest to build on that structural knowledge. And so, yeah, there's things like growth rate for T-Rex and jaw function and muscle articulation and how fast it could run and how fast it could accelerate and how fast it could turn or how well it could turn and its physiology and yada, 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 and loads of papers like this. And that's basically just not been done for any other dinosaur ever.
And we've got loads of, like, hadrosaurs.
Well, right.
We've got loads of
or, even something, to pick an obvious one, like Triceratops. Actually, if you really want to understand T-Rex, this is, Triceratops and Edmontosaurus, the hadrosaur, the two things it probably ate most and are some of the most numerous things in its ecosystem that are not it and are big herbivores. Yeah, we've got loads of complete skeletons, more of them than we do for T-Rex. So we know how to do all that stuff because we've done it once. Similar to kind of the Liaoning prospect, we just need to apply that, and that's decades of work from dozens of researchers. So it's not that it can't be done, it's just that it's a monumental effort. But we know how to do it. It's just a question of applying that knowledge.
We've got to get excited about Triceratops, is what you're saying. We've got to have like a really sort of big Triceratops pad, and then loads of people do their PhDs in it.
It's things like this that I'd love to see done. Like you say, there are, to slight frustration, I've genuinely tried through a couple of the vague connections I have to a couple of very, very, very rich people who are known to buy dinosaur skeletons and things at auction and suggest to them that if they're actually happy to spend $200,000 on a skull of something, might they like to consider dropping $20,000 on a university to fund half a PhD on this animal? Or even another $200,000 to fund 3 or 4 PhDs on this animal.
I think what we'd need to do is make PhD students a lot more attractive at parties, and that way you could show off your PhD student. So if they're all a bit like, Tony Stark in Iron Man, if they had that sort of like, hey, charisma, then you could like sell them as like, oh, look, this is my friend who knows all about dinosaurs. Yeah, even then you wouldn't want them at parties. No offence, Dave, but a skull is really cool to have at a party, in your living room and in your study. Whereas
you met me again at a party that I was invited to.
I did meet you at a party.
As a paleontologist, so clearly
you were invited because you were a paleontologist, and I had to drink a lot of gin that evening. So. Drink responsibly.
These are, these are things we can do. We just haven't done.
So what we're going to do first then? What do you think's most likely to, of these things are going to get done soonest? Look at your face. You don't know, do you? You've written this book and you don't know.
At the end, I put together some speculative stuff about things that I think might change very quickly, particularly in terms of research. So, we've talked about this before, I'm fairly sure, but when I was doing my PhD, or certainly towards the end of my undergraduate in the late 90s, if you wanted to find a research paper, so say you wanted to look at something like dinosaur footprints, you'd go up to the library and they had these big fat volumes, and I mean like encyclopedia-sized volumes. And every year a bunch of companies would publish these things for their various journals. So you would pull out the 1997 to 1998 volume, and it basically had a list of keywords, like a little dictionary index, and underneath all the papers that included that in their paper.
And probably not even in their paper, in their forward of their paper. What are they called? Not the forward.
Well, the abstract. So, what you traditionally have is the title, the abstract, and then some keywords. So dinosaur behavior, footprint, trackway, Utah, Cretaceous, something like that. And so, you would be looking up Cretaceous or looking up Utah or whatever this word was. And then just looking through the list of papers to read the titles and see which ones looked interesting. Then, even then, we could actually go to a computer and look those papers up to get the abstract. But then you had to go and find the physical paper in the library. So you'd wander off and find P under paleontology in the shelf.
Tell me about the olden days, Grandpa.
No, but I know, but I'm getting there. This will come round to a point, honest. And pull that off the shelf if we had it, and flick through and take a look. Or if we didn't, go to the front desk and write it down, and they would send that off to another library that they knew had that, who would then stick it in the post and send it back. And you might have to wait 2 weeks or even 6 weeks for that. And then you got it out and you opened it and you went, oh, this isn't very interesting at all. It's not what I needed. That process to even find the paper could take 20 minutes. And then, again, it took take weeks to get hold of it and discover it was useless. And now I go google.scholar.com, dinosaur tracks behaviour, Utah Cretaceous. Oh, here's 200 papers that have been published on that subject. And I'll download. Oh, that one looks quite good. Download. Oh, that one I don't have access to. Oh, there's the author's email address. Hi, can you send me that paper? Cheers, Dave. And in those same 20 minutes, I might get 100 papers that I can work on. And I don't think anyone really saw that coming in the late 90s. We thought this was going to get better and more useful. But, that whole transition of the web. And when you think about, just productivity, the fact that, as an undergraduate and even in the first days of my doctorate, I could quite happily spend a day in the library to come back with 4 or 5 papers of which one might be useful. Like the collective knowledge of paleontologists spending years annually doing that to not find what they wanted, and now it takes minutes, just means that everyone works far faster and far better and more effectively and efficiently than they could ever before. And boy, is that great.
I have a question about, because talking future technology, and that's the thing, because I think in a past episode we talked about just the amazing ability just to be able to go, can you send me a photo of the specimen? Can you send me the measurements of because a friend of mine made me a tiny little articulated velociraptor. It's not like thing, but it's really cool. Yeah. It moves and everything else. And I was just thinking, surely now we're going to be able to scan samples of fossils and be able to print them.
We've already been doing it. I mean, that's been around forever. I did 3D printing of a fossil in 2005, 2006. This is a long time before most people knew that this could be done. There's an obscure article in a German magazine about us doing it. And then we
a journal, not a magazine.
No, a magazine. It was an engineering magazine. So there's
aren't they all in Germany?
So it was while I was doing my postdoc in Germany, and I was working on a Rinkosaur that I'd done my PhD on. We were finishing up another paper on it, and a colleague of mine came to me and said, I've discovered this little company who do some odd bespoke engineering things for Ferrari, I think, actually, for Ferrari's F1 team, among other things, because, they really were like 3 guys in a shed who did like a couple of things, and they were the best people in the world at it. And, that's how Formula One works. And they've got this thing where they can like scan an object object, and then they weren't printing it in the sense that you see printers now where they kind of print stuff out. What they're actually doing was carving down. But obviously the process was still effectively the same kind of thing. You would start with a fossil and start with a block of resin and end up with a block of resin that looked just like your fossil. And we went and did it as a trial, and it worked pretty well. And we made 2 copies, one of which is in Munich and the other of which went back to Bristol with the fossil. And yeah, what we tried to do was then digitally manipulate the scan to fix some of the broken bits to then restore it and print it. And this in 2006 was really hard. And Tom Fletcher, who's now at Leicester, I think, and was then doing it for his undergraduate project, I think, tried to do this. And basically, it's not that it didn't work, it just took forever and it was never very good. And by that time I'd left, so we didn't really have access to the German company anymore. And the guy who introduced me to them had left, so we didn't have access to him anymore. And yeah, we just never finished this little project. But that remains a great frustration that we could have basically done 3D restoration and printing in almost the first half of the 2000s decade. About 10 years, I think, before anyone else actually really did it.
And people are doing that now, though.
Oh, absolutely, yeah. Even just the 3D scanning of images and 3D modelling. I mean, there's a good. We talked about photogrammetry
a little bit. We talked about it, I think, when we were talking. Was it when we were talking about the T-Rex in Japan? And I can't remember
possibly.
Why. Or just walking into any museum and just taking random photos and being able to build the model of that fossil later.
Yeah. So almost exactly 10 years ago, I first did a little. Well, I didn't do any photogrammetry. I had this Triceratops block with 4 little babies in it. And I'd taken loads and loads and loads of photos because it was in Japan. I knew I wasn't going back anytime soon. And then Pete Falkingham, who's at Liverpool John Moores, Pete was doing really cool photogrammetry stuff on footprints and things like this. So yeah, taking loads of photos, building a digital model. And I was at a conference in Oxford, I want to say, that Pete was at, and he gave a presentation of this. And I went, Pete, I've got like hundreds of photos of this thing. Is that all you need to build a model? And of course, I hadn't done it systematically the way you should have done with even lighting and yada, yada, yada. And he went, yeah, but I can have a go. And he took my photos off, he stuck it on his machine. Again, USB hard drive, something that was completely alien in 2000. And he said he left it running overnight and he came back the next day and here's your little 3D model that I could move and twist and rotate. And this was amazing. But to do it well, you really wanted like something on a turntable so you could move it an even number of degrees and a really good camera and really good lighting. And now we're at the stage you can do it on a phone. Like you can just get a phone out, turn it to video, not even take photos, walk around a skeleton and wave your arm around and poke it into all kinds of different areas, and then export that video into a software which will basically take every single frame of your HD phone video and separate them out into a separate image and then build the 3D model off that. And so yeah, again, within 10 years we've gone from, to do it well, you need a really good camera and to spend ages on this and set all your lighting and balance up to, any idiot can do it in about 10 minutes with an iPhone. So yeah, again, where are we going to be in another 10 years from now? The level of fidelity, the quality of those images, our ability to 3D manipulate them. Are we going to start automating processes? Like, just tell the computer, this is what I want to do. I'm going to take the video and you build the skeleton. And by the way, I want you to take out all that metal stuff off it. And I want you to color grade it. So anything which is a different color is probably not bone. So you can take that out for me. And it will probably just do it.
And then you can just do your investigation and write. Maybe it might even be able to articulate it as well for you if you tell it where the joints are.
Yeah.
Maybe it'll know where the joints are.
Well, right. I genuinely think futurism is everything's 10 years away or 50 years, 100 years away. But that acceleration of those kinds of things, and if you look at the work being done for things like biomechanics of dinosaurs and those, working out where all those muscle attachments go and things like this, again, you can probably automate that. Like the computer will go, okay, I know a bone that funny shape. That's a scapula. I know scapulae should have things about here for muscle attachments. Yes, there it is. That little thing there is a muscle attachment. A muscle that attaches there finishes here. If it's that wide here and that wide here, it's this big. If it's that big, it's this strong. And just do that for all the muscles of the skeleton. And then you can go, cool, how fast did it run? Well, it just does it because it now knows how big the skeleton is and it's already weighed it for you and done the mass estimate, and then it's done the muscles for you, and now it can work out how every individual muscle moves optimally, and it will, it can run this fast and it can accelerate that much and it can probably turn to this degree, and its neck flexes 20 degrees up and 40 degrees down and 70 degrees sideways, the rotation of 70 degrees, and it could just do all of that.
And any missing data, it could probably do like several different models.
We've talked about doing phylogenetic analysis, coding hundreds, thousands of these characters. Again, huge amounts, like the work doing to set that up will obviously be colossal. But, why, I don't see why eventually, decades from now, that can't be automated. That's a scapular. It's this long and this wide. The ratio of those is this. That counts as this. Or that joint, okay, I will do an analysis of every single bone that you've shown me that has that curvature, and I will measure them all, and I'll calculate a distribution, and I'll find a separation, and I'll use that to create a binary system, and I'll code that in, or I will consider it a numerical value. Oh, and it's already that old, and I've already checked a database to see who, what age the specimen is, and automatically calibrate it. And it'll just do it.
And it'll build a perfect little model, and then you'll have people like coming online in the metaverse to watch these models fight. And then everybody will be very happy with that, and paleontology will get a lot of money. One thing I did want to say is I've noticed that with scientists in particular, it's always in a few decades or in a decade, it's the same thing as when you're 30, things are always an older. So if you're 30, if you're 40, if you're 50, if you're 60, everything's always 10 years ago.
Yeah.
There's a time in the past, it was about 10 years ago. And yeah, that remains true. So when you're 40 and you're thinking something you did when you're 21, that was about 10 years ago. When you're 60, it's about 10 years. That's always the way that we perceive time is fundamentally flawed.
Definitely. I mean, I had to do that when I wrote that chapter. Again, we've gone off into things that aren't really in the book, but
okay, we'll go back to the book in a sec.
But I do talk about like that, that development of research and all those unexpected transitions, and just how much more is coming from things like CT scans, which are getting better and better and better, and we can probably automate chunks of that to make it even faster. But yeah, when I wrote, I did write a little introduction to the research chapter explaining all of that stuff of the paperwork, because I think most people wouldn't realise it. And even people who are older, if you're not a scientist, you wouldn't understand that that's how we had to find things. And yeah, I was kind of writing, about 10 or 15 years, nearly 30 years ago.
It is, yeah.
Yeah, just scrub that. So, all right, not quite,
Everybody I know who went to unis in the 2000s, between 2000 and 2010, thinks of 1990 as 10 years ago. They always the 90s are 10 years ago, and no, this is not the case.
Yeah, I saw something. Yes,
10 years ago is 2012, when the whole world ends.
I know. I watched some video on YouTube, and it was dated 1992, and I went, that's quite 30 years.
Yeah.
Oh. oh God. Yeah.
It's crazy. So what else do you talk about in your book?
Oh boy, there's a chapter on behaviour. Obviously, I love my behaviour, and I talk lots about that. So again, these, talked about colours and signalling, which we've already mentioned, but the social biology stuff, part of that there's an interesting one in that, A, we need a bunch more fossils, but B, in some ways, our understanding of what's driving this in living animals isn't great. And of course, if you want to work out what extinct animals are doing, a much better understanding of what living ones are up to and what exactly drives that under what set of circumstances. Social groupings. We know that animals coming together to groups can be driven by things like predation pressure and a lack of resources and, cooperative breeding, which in itself can be, trying to avoid predation pressure as well, and things like this. But that's going to vary for lots of different species in lots of different ways, depending on all kinds of different conditions. And that we really don't have a very good handle on. And if we could get a much better handle on that for living animals, how much is that affected by how big you are, or how dry the climate is, or how many babies you have, or how big the predators are, or how many of them there are, or what type of them there are. That then becomes your massively improved basis for understanding what extinct animals are doing, including dinosaurs.
Is there as somebody who knows very little about any of this, is there a distinction between, extant dinosaurs and modern birds in the way that they flock compared to mammals, in herds, or even dolphins and pods and things?
To a degree, partly at least because, birds are so much smaller than mammals, and even the comparably sized ones just move so differently. A mouse getting from one end of a forest to another would take an age. A sparrow, if it really went for it, could do it in a few minutes. Right, but
sparrows always really go for it, though. They're very determined.
But even comparably sized animals with actually quite comparable diets, as small sea weed eaters, they're using terrain so incredibly differently that it's pretty hard to compare birds to terrestrial animals. And then, of course, there's the, particularly certain types of flocking that gives you an efficiency in the air. In particular, things like, V formation ducks and stuff, but other stuff gets benefits from flying in groups as well. And then in particular mass aggregations, it's probably large, at least in part, a predator defense. If a hawk is going to go for you, if you're one of 100,000, probably not you, unless you're very unlucky. If you're on your own and it spots you, you know who he's going for. But also, depending on with birds, they're moving around between resources. If you are in a group of 100,000 birds, you're going to eat every seed in that field pretty quickly, and then you've got to go to another field. So everyone's going to move because everyone's going to run out of food at the same time, and no one wants to be the only one sat there. So that really will drive things. And of course, birds can see a long way, in part because they fly. A mouse on the ground, its horizon is limited. People do this who trap or shoot pigeons. Capture a pigeon or even get a wooden pigeon and stick it out in a field. Other pigeons are flying around and go, oh, they found something to eat. I'll come and land next to them and see what they've found.
They found a gun.
Well, yes, but that's why that works, because things like wood pigeons are flying around. Oh, there's a bunch of wood pigeons there. I'll go and join them. Other wood pigeons are soon going to see a group of 20, which becomes a group of 30 and 40 and 50 and attracts more and more and more.
It's really weird when you see that many wood pigeons, because I do, where I go walking down in Southern Woods, there are fields, farmers' fields, and particularly you see them after the harvest or as they've been sowing, and there'll just be a field full of wood pigeons, and usually you only see
2 or 3 or 4, yeah.
Yeah. And then suddenly, there's about 65.
Yeah.
All going flap, 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 flap. When you get within 300 yards of them, they don't like...
Yeah, all that kind of stuff is going on for birds, which, can't really work for animals that don't fly because they just don't have that, level of view. So yeah, there are going to be very different pressures affecting sociality in birds compared to mammals or reptiles, and therefore that's going to be changing.
Or
things.
Ancient dinosaurs.
Well, yeah. I was considering the dinosaurs in the reptile comment, but yeah. But again, that's why, we've talked about that before. We talked about behaviour. You've got to take this very broad approach, which makes it difficult to bring this stuff back together.
Do you think there's going to be some sort of philosopher with a sort of game theory for animals and that,
various bits of that have been done, of course, but this is the classic problem with behaviour, at least from trying to restore it for things like dinosaurs, is that it tends to be in a fairly narrow perspective, because the only way you can really work it out is to put it under experimental conditions, so that there is only one factor affecting these things. You've got rabbits or rabbits or mice or canaries or whatever they are in a fairly sterile box, and then they have a choice of doing two things, or they're observing something and then we see what they do once they've observed it, to try and make sure that there's only really a single driver for what they're doing, or that you're only manipulating one experimental condition. And that means that stuff is pretty slow and hasn't been done on many species and only works out certain things that work well.
And particularly only small things, because
yes.
Otherwise you need a big box.
Right, and curiously enough, we haven't really tried it for elephants or rhino or, even stuff like rabbits are actually a bit big for that kind of thing a lot of the time. So yeah, it tends to be mice. And mice are interesting and all, but they've probably got different social pressures compared to buffalo.
And also, white mice are conducting experiments on the human race as well, as part of, deep thought. Computer trying to answer the universe and everything. Big question, yeah. What behaviours can we find out about then? Is it just a case of saying, oh look, we found out wolves do this, therefore brontosaurs did that? I don't know.
Yeah, probably not, but certainly I've argued for greater, not quite scepticism, but I think there's been a tendency in the literature for stuff like footprints to be over-interpreted. Here is 2 sets of tyrannosaur tracks moving together, therefore they're living in groups. And you're like, well, that could be one following another, that could be one trying to chase one off, that could be a juvenile with its parent, that could be a chance association, that could be a breeding season, a male tracking a female, that could be a male trying to chase another male out of his territory. All of those are equally plausible interpretations of those kinds of footprints, and there's no real way of picking between them. So certainly, a better understanding of what kind of things drive animals to come together, which of what I've already said. But then when that leaves trackways, what does that mean? So something I've been really interested in, this isn't in the book. Well, but it's making a point that that wouldn't work very well in the text. But things like, inverted commas, game trails. If you've ever been anywhere out into the wild looking for animals, you will come across paths that animals use. And of course, it's very hard to tell when that's human-made in the modern world, even if you're in the middle of nowhere, in Africa or Asia or wherever. But animals also use those paths. When I'm down in the place we go to in South Africa for our fieldwork, there's a whole bunch of literally human-made paths and even roads around the edge of this game reserve that we're on. But yeah, there are leopard prints going up and down them and giraffe track going up and down. The animals follow these. And in the real wild, you will find paths which are made entirely by animals. And other animals use them because it's more efficient. But I'm aware of almost no research on this, as in just how much do animals use things like paths or the edge of rivers as routes around to get places. And that's quite important because that's the kind of places which will generate lots of footprints if you're trying to interpret their biology. And so, yeah, if you can work out, even if it's just a vague estimate of how much these kinds of environments tend to drive certain types of grouping behavior or apparent grouping behavior, that will really help. So that then feeds into things like taphonomy and preservation. This is stuff I do talk about. We've talked about, footprints sinking in, again, Pete Falkingham again, we talk about footprints sinking into the ground, and when they lift up, that leaves a surprisingly different shaped footprint to the one that might occur from the same foot on more solid sand, for example. But if you can work out from, say, the state of that footprint, how quickly that sediment might have dried, that then becomes really interesting. So that 2 Tyrannosaur example I gave, if you can go, those footprints must have been laid down within about 5 minutes of each other. Otherwise, the first one would have dried and then the second one would have barely left any trace at all. That then tells you that they really must have been right on top of each other. Now, that still opens a whole bunch of different interpretations, but it's very unlikely to be a male tracking a female, half a day along because he's picked up the scent and he's interested in mating. That at least would rule that possibility out. Or in some cases, and I can conceive of this for, very small footprints, for very light animals and very fine sediments. Oh yeah, we've done some experiments and that stuff dries in like 5 minutes. So if there's 200 tracks, that absolutely is a group of 3 or 4 dozen animals moving together, because otherwise they wouldn't have left those prints at that point. And so, yeah, again, experimental work on modern environmental conditions can absolutely feed back into trying to interpret and understand behaviour of long extinct animals. All it's really doing is narrowing your window down of possibilities, but that's still extremely useful when you couple it with evidence that we have from other things.
Actually, I sympathise with any scientist who has to do that, because I did lectures on mud and the causes of mud, and they were at 9 a.m. Bless the guy who taught us, but he was not the most engaging. As you can imagine, a man who spent his life researching mud
yes,
and infiltration of liquids into mud, and how quickly certain soils dry, and how you're meant to irrigate certain fields depending on where to plant the trees and all. Oh my God. Anyway, yes. Also, that whole track thing, I'm very, for efficiency of paths. I know this is a big thing actually in town planning where, you can't, for example, have a green and then have a lovely winding footpath
Desire
through it,
lines.
People just cut the corner,
Yeah, they just go straight
exactly. Through. And when we designed our garden, as in when we put down paving slabs, we just followed the cat path down to the end of the garden because it's the most efficient route.
But absolutely, and I would argue that on average, we as paleontologists need to spend more time looking at living animals and what they do. It's just difficult because the biologists want to do that work, and they're often very interested in very different things to the rest of us.
Do you come to a conclusion in your book, which is, let me guess what the conclusion is: paleontology needs more money?
No, I didn't say that. There is. I have to say, there's probably no real conclusion, because I'm just, I guess, advocating a position that we found a lot out, but for everything that we found out, there's even more that we don't know. And again, they've got these two not quite non-overlapping categories of things we're probably going to work out sooner or later, and insane stuff or things that we just simply can't work out or or, again, I said colour was something we'd never work out. It turns out that we did, perhaps never say never, but it does seem rather unlikely that the late Cretaceous equivalent of Hawaii is suddenly going to rise up from the ocean again with thousands of well-preserved dinosaur fossils just sitting there waiting for us to open them up.
I'm still hoping that there'll be a way of looking at surviving proteins and working out that they can only be linked to certain types of DNA in certain places in chains. And
that's at least possible, or at least potentially, because I don't know anything like enough about that kind of stuff, not being a biochemist or taphonomist or working on any of those kind of subjects at all. A lot of this stuff just comes down to the data, in the sense that either we've yet to dig up the fossils that we need to answer certain questions, or we have got fossils that probably can answer them once we've worked out the kind of methodology.
So who is your book for? I want to know who your book is for. Is it for people like me, or is it for a bit cleverer people?
No, it's absolutely written as a popular science book. It is
cool.
It is a general book. It requires no real technical knowledge, and a lot of the people who listen to Terrible Lizards will probably find several of the chapters a bit boring, because they're lots of what is a dinosaur, what are the different groups, how are they related, why do we know that, because that kind of background information the average person doesn't have, and I kind of need to put it in. But yeah, it absolutely starts from near enough zero knowledge. If you're a general average person with some interest in science and the world around you, you're gonna be fine.
Yeah, you say general, but I think I'm average.
And if you're not, you're probably not gonna be buying it anyway.
No, you will be. I'm sure. I think if you're an idiot like I am, you should still have a go. I think that is. And who's publishing it, and where can people find it?
So in the UK, it's published by Hodder. It's already, I've seen it on Amazon, which means it's probably available in other places as well. It is coming out in North America. Princeton University Press have bought the rights to it, so it will come out under Princeton rather than Hodder in the US. I was told we pushed the publication date in the UK back to accommodate the US release, but at the time of us recording this, I've not heard anything about the US release yet. Hopefully it's out either on the same day or relatively soon afterwards, but if you're in the UK or Europe, it should be readily available already. If not, if you're in North America, it's coming. I'm not aware of any translated issue yet, but like the Tyrannosaur book, it'd been out for like 18 months before we got commissioned to translate it into Russian. So I don't know, maybe other editions will follow. It's available as an ebook. It's definitely available it's going to be available as an audiobook.
Ooh, will you be reading it, or will somebody else be reading it?
Not me. Someone else will be reading it, because they've already lined someone up to do it. But yeah, so it will be available as an audiobook. I believe it's already available as an ebook.
Should be. Most places do.
So that should be more internationally available already. But yeah, other than that, bookshops probably.
It's exciting. So yeah, go buy this book, people. This is what we're telling you to do.
Well, telling is, as you know, I'm rather self-effacing, and being British, I'm terrible at this. Hurry up and give me money, people, because no, I don't like doing that. I'm not very good at it. And yes, I have written a book, and it'd be nice if people bought it, but for God's sake, people listen to this. I mean, they don't have to give me money as well.
No, they do. Patrons do. Well,
I know, and I'm still not sure why, and it's very generous of them.
Because it takes us a long time to edit, Dave.
Well, yeah.
So you know what you need to do now, our listeners. One, you need to sign up to Patreon. Don't listen to Dave. It's very important. Two, can you please go and order his book, buy his book. It is very good, I am sure. I haven't read it yet because he hasn't sent me a free copy.
Because we haven't got it, because I haven't got one yet.
So go buy it and tell your little friends. I know we're paleo people, so we don't tend to have many of those, but we must have some.
As discussed, we don't get invited to parties because we're not very interesting.
Well, this is the thing. Billionaires' parties, and who wants to go anyway? They just want to look at the dinosaur skulls. That's the only way they can make friends. Right. So, ladies and gentlemen, boys and girls, please go and buy. What's it called again, Dave?
The Future of Dinosaurs.
The Future of Dinosaurs. I think that's a good title. I like. Publishers did good. I think it's good. He's looking cross, but it's a good title. So go buy The Future of Dinosaurs. It is by Dr. Dave Hone. He's called David Hone, I assume, on there.
Yeah.
Yeah, it's not Dave, it's David, because he used his full name, because his mum wrote it. So we will say until next week. Thank you for listening to the Terrible Lizards podcast. To support the show, share this episode and leave us a review, especially with dinosaur emojis, on your app of choice. You can also become a patron on patreon.com/Terrible Lizards, where you will be rewarded with extra content. For more information about Dave and Izzy and our books, other podcasts and blogs, please visit terriblelizards.co.uk. We hope to keep making this content, and it's down to your support that we do, so thank you.